Okay, so this last example by substitution, I solved for y in the first equation, and I got negative 6x minus 27. Substituting it in, I came down to x equals negative 5, as you'll see here. And then used that to plug in back to my y equation and came down to y equals 3. So your final answer here is negative 5, 3. All right, the final method we're going to look at today is the elimination method. So you multiply, step 1, multiply one or both sides of the equations. Multiply one or both equations by a number to result in two equations that contain opposite terms. So what it means by opposite terms is like 2x and negative. Right, so one equation will have a positive 2x, one will have a negative 2x, so that when you add them together, they cancel out. Step 2, you add the equations, eliminating one variable, then solve the equation, and then finally you substitute in to solve for the other variable. All right, so for instance, this first example, I have a negative 3y and a positive 3y. So these already have those opposite terms needed in step 1. So what I can actually do is add these two equations together. So I have a 4x plus a 2x, which gives me 6x. I have a minus 3y and a plus 3y. And having those opposite terms means they cancel out. So I'm left with just 6x equals negative 22 plus 16, which gives me a negative 6. All right, so what I have now is negative 1. I can now use this x equals negative 1 does not matter which one, to solve for y. I'm going to plug it into this here. All right, so 2 times x, that's negative 1, plus 3y equals 16, gives me a negative 2, plus 3y equals 16. So 3y, add the 2 over, equals 18, and I come down to y equals 6. So my ordered pair here is negative 1, 6. And just with substitution, with graphing, you can always check your answers by plugging those back into both equations and making sure that they both work. All right, so if we look at this next example, I have 6x minus 5y equals negative 8, and 4x minus 5y equals negative 12. Well, right now, I don't actually have opposite terms, but I'm really close. Negative 5y. So what I'm actually going to do is I'm going to multiply this way. My first equation will stay the same. My second equation becomes negative 4x plus 5y equals a positive 12. Now, when I add together, my 5y's are going to cancel out. So I have 6x minus 4x, that's plus a negative 4x, 2x. My negative 5 minus positive 5y cancels out. And my negative 8 plus 12 is positive 4. And I come down to x equals 2. I can now use that x equals 2 in any of my equations here, my original equations, to solve. So I'm just going to go ahead and substitute it back to this original 6. So that's 6 times 2 minus 5y equals negative 8. 6 times 2 is 12 minus 5y is negative 8. So a negative 5y, subtract the 12 over, gives me negative 20. And I come down to y equals negative 20 divided by negative 5 is positive 4. So my final answer here is the ordered pair 2 of x values for my y value. So elimination can be very helpful. When you look at this next example, you could go about this a variety of ways. I see the 2 and the 4. So what I'm thinking we're going to do is let's multiply this first equation. Now I need it to be a 4, but I need it actually to be negative 4. I'm going to multiply the entire top equation by negative. Right? So right now, if I multiply everything by negative 4x, a plus 18y equals 34 times negative 2, negative 68. Leave my second equation alone. Add them together. My 4x's cancel out. I have a plus 18y and a minus 6y. Gives me 12y. Equals negative 68 and a positive 18 gives me a negative 50. So I come down to y equals, see here, negative 50 over 12, which reduces nicely to negative 25, 6. So elimination is really helpful in a situation like this when you have fractions. So now I'm going to take this y equals negative 25, 6, and I'm going to plug it in to this equation so that when I multiply here, my 6 is cancel out. So now I have 4x minus 6 times negative 25, 6 equals 8. Here, my 6 cancels out with this. So really, I'm just left with 25 here, positive 25 equals 18. Come down to 4x equals subtract 25 over negative 7. So my x is negative 7/4. So my final equation here, my x's, or my ordered pair, negative 7/4, my y, negative 25/6. So finding that graphically would be really difficult. In substitution, it's even a little trickier, but elimination, it worked out pretty smoothly. Yes, you may have fraction answers, and that's going to be fine. Right? So what I would like you to do is get started on this next one, and you may run into an issue or two, so we will talk about that right at the start of the next video.